Good day, guys. Today we are going to be doing Newton's laws. Newton's laws is a really important part of the grade 12 technical sciences syllabus. It accounts for a large portion of your exam at the end of the year, and it's of the first questions that you guys will encounter within the final exam. Now, you also have to know it's going to come in the March paper this year. It's going to be coming in the June paper as well as the September paper. So you guys will do well to do your best within these laws. Newton's first law states here that an object continues to move in a state of rest or uniform velocity unless it is acted upon by a net force. What does this mean? Well, let's go into an example, and I'm going to use the example of a block on a surface. This block weighs 5 kilograms and the block is standing still. When this block is standing still, this is an example of an object in a state of rest. Guys, it's as simple as that. And if this block is standing still, it's in a state of rest, that means that it will stay in that state of rest unless we act upon it with a net force. For example, if someone takes this block and he pulls it with a force of 5 newtons, then something may or may not happen. Regardless, this block is in a state of rest and there's no force over there. But let's look at the forces that are there. So as you guys can see, we have the 5 kilogram block. There's no force going to the right, there's no force going to the left. However, there is a normal force that acts upward, and we have a force of gravity acting downwards. And as you guys can see, the block is not moving up, the block is not moving down. So were we to look for the net forces acting on here, or all the forces that make up the net force, we will say that the net force in this circumstance is equal to the force normal plus the force of gravity. Now as you guys can see, it's not moving up and it's not moving down. Therefore the normal force will have to equal the force of gravity. Now if that's the case, if the normal is equal to the force of gravity, and as you guys can see they act in opposite directions, we can ultimately say that the net force will equal 0. Let's assign an arbitrary value to the normal force. Let's say that the normal force going up is positive 5 newtons. And we know that the force of gravity is going down, so that's going to be negative 5 newtons. Plus 5 newtons plus negative 5 newtons is ultimately going to give me 0. And that's how the law is basically explained. Not completely, but that's just a way of trying to understand it. I'm going to use another example. Let's say, for instance, we have a block, and that block is 10 kilograms, and it's moving along a frictionless surface. So there's no friction occurring over here, and it's moving in this direction at 2 meters per second. So there's no force pulling it that way, it's just moving at 2 meters per second. There's no force pulling it this way, there's no friction. So the only forces that occur on this block again is the normal force as well as the force of gravity. Meaning that my F net is equal to Fg plus F normal, and they will cancel each other out, and my net force is going to be 0. So you guys can see within constant motion and stationary motion, or stationary state, or a state of rest, the net force is equal to 0, and that is basically Newton's first law. What's important and something that you guys need to remember is the fact that this law over here comes from your exam guidelines, and you guys need to know it precisely like that. And it states an object continues to move in a state of rest or uniform velocity unless it's acted upon by a net force. So the main equation that stems from this is F net is equal to 0, and we will jump into some exam examples later that will help you understand this equation. You guys have also learned in grade 10 physical sciences that F net, or the net force, or the net of anything, is equal to the components. And in this case, the components of a net force is going to be the first force plus the second force plus the third force, and so on and so forth. What do I mean by this second equation over here? Well, let's have a look at the block. And we have, going to the right, a man pulling this block with 5 newtons, and let's say he has a partner that pulls the block with 10 newtons, and then we have a frictional force going in the opposite direction, and let's call that frictional force and that has a value of 12 newtons. How do we calculate the net force in this circumstance? According to this formula over here, it's very simple. The first thing would be to choose a direction as positive. Okay, let's choose a direction as positive. In this case, I'm going to say let right be positive. Then I'm going to write down my formula. F net is equal to F1 plus F2 plus F3. Now, what does F1, F2, and F3 actually mean in this circumstance? Let me show you guys. Well, you guys can see this F1, and I can assign my F1 to be 5 newtons, or the 5 Newton force over there. So I'm going to go F1, 5 newtons. F2, I can choose to be my 10 newtons. This is how it's going to work, 10 newtons. And what about my frictional force? Well, remember guys, I told you that right has to be positive. So if right is positive and I can clearly see that my frictional force is acting in the left direction or west, we're going to have to add it in here as a negative 12 newtons, right? So that's 5 plus 10 minus 12, and we're going to end up with 3 newtons to the right. And that's one way of calculating the net force, guys. So this over here is an example of using the second equation, and we're going to be using these two equations in conjunction with each other as we try and solve exam problems a bit later. Let's move on. So the next term that we have to memorize, something that's asked quite often in the exams for 2 marks, that is called inertia, and we have to understand inertia as well. So what is inertia? Well, inertia is the property of a body to resist any change in its state of motion or rest. And what does that mean? Well, if I can give you guys a simple example, if I have, again, a 5 kilogram block, and it's on a surface, and it's standing still, and I pull it with 5 newtons of force. 5 newtons is a relatively small force, and what's going to happen is the block is going to struggle to move, or it's going to resist a change in its motion. That resistance to change in motion, that's known as inertia. Another example of this would be if we are driving a car. Here's my car, and I'm sitting in the driver's seat. There I am, and the car is moving at 5 meters per second, and suddenly I see someone running. Here's my crossroads, there's my other road, and I see someone running over here. I need to suddenly brake. Well, what happens when I suddenly brake is I'm in my car, and as soon as I suddenly brake, what I find is that I myself, I lunge forward in my seat. Why is that? Well, the thing is, the car and my body is moving at 5 meters per second. And when I brake the car stops, but my body continues to move in a forward or 5 meters per second speed. My body is resisting the change in motion. You guys get that? If you do, you do. If you don't, you don't. There are some other examples, but I'm sure you guys will understand that a bit better when we do some examples a bit later. Next, the next term you guys need to know or understand, at least, I'm not sure if they ask this within the exams in terms of pure definition, is mass. So mass is a measure of inertia of a body. What does that mean? Well, if I have a 5 kilogram block, again I'm going to use this 5 kilogram block, I'm using it all the time. I have a 5 kilogram block, and I want to move this block. So here I am, and I give it a bit of a push. The block's obviously going to resist me with a certain amount of resistance, known to us as inertia. If I have a heavier block, 10 kilograms, and I push it with the same amount of force that I push the 5 kilogram block, it's going to offer me more resistance. Or by nature, this 10 kilogram block is going to be a bit harder to move than the 5 kilogram block. Why is that? Because it has a higher amount of mass. Whenever something has a higher amount of mass, it has more inertia. So mass is a measure of the inertia of a body. You guys, it's still in the exam guidelines. That means they can ask it to you guys as a definition.